These are the polynomial long division notes. So first I want to start off with a couple notes. This is very important because we're going to need to know how to do this to find horizontal asymptotes of rational functions. And this is going to make sense in about a week or so when we actually start looking at rational functions, when we start talking about horizontal asymptotes. So this is going to be a little bit down the line, but it's important that you know how to do it now. And it makes sense to do it right at the end of polynomials as opposed to doing it in the middle of rational functions. Now, I'm going to acknowledge that there's not any real-world scenario where you're going to have to do polynomial long division. When you're actually out in the real world, if you're doing anything that would require looking at a rational function in any way, shape, or form, you're going to be doing this with some graphing technology or some data analysis technology. This is not something that you're doing this. You're not doing this with by hand anymore. We're well into the age of technology. However, with that being said, this is going to help you with your AP calculus exam. If you know how to do polynomial long division, if you know how to establish what your horizontal asymptote is via polynomial long division, it's going to help you if you're in the no calculator section of your AP calculus exam. That's just a fact. That's something that you're going to need to know for next year. So you need to be able to do this polynomial long division. Also, this helps you understand why a horizontal asymptote exists. It helps give you the information of do a horizontal asymptote. It helps you understand what a slant asymptote is. It helps you understand these concepts. So it's one of those things, if I just showed it to you on a graphing technology, you might be able to do it, you might be able to explain it to me, but you might not understand it. By doing the polynomial long division, we're going to be able to see it much more clearly. So we still are going to learn this because it is an important skill, and it will help you A, with understanding, and then B, with success in AP calculus next year. All right, so we're just going to break it down. We're going to do polynomial long division. What I have here is I've got x squared plus 6x minus 10 divided by x plus 2. So we're going to set this up just like we set up regular long division. We're going to set up a doghouse. We're going to set up x squared plus 6x minus 10, and then we're going to put x plus 2 outside. So this is something that's important. We always have to remember what we're dividing by goes on the outside of the doghouse, and what is being divided goes on the inside of the doghouse. The other way that this could be written would be x squared plus 6x minus 10 over x plus 2. And we're going to quickly see how, when it looks like this is basically a rational function. Right now, we're not saying this is a function, we're just saying that this is two expressions that we want divided. And so either one, it could be written either way like this, and that means we're going to divide the polynomials. So what do I do with polynomial long division? Well, I want to know what makes this term look like this term. What would I have to multiply the first term of my divisor by to make it look like the first term of what I want divided? And in my case, that means x. And since it's an x, I'm going to put it above the x position. This really isn't really important. You can put that x wherever you want, but this is just kind of one of those things that mathematicians tend to recommend because it makes things a little bit better. And what that means is I want to multiply my divisor by this x, but I'm going to multiply it by both terms. So I need to multiply that x times that x to get x squared, and I need to multiply that x times that 2 and make that 2x. I'm going to distribute that x to both terms of my divisor. Now I'm going to go through and I'm going to subtract. And you always subtract here. When I do this, I've got x squared minus x squared. I've got 6x minus 2x. I distribute this to both terms. I am left with 4x. I did nothing with this minus 10. That will come down. Now that I'm here, I'm asking myself, okay, what do I multiply this by to make it look like this? I need this x now to look like this entire term. Well, that means I have to multiply it by positive 4. So I'm going to put positive 4 up here above the ones place. I'm going to say I've got 4x plus 8, because 4 times 2 is 8. I'm distributing that 4 to both terms. And then I'm going to subtract the entire term. My 4x cross out. I'm left with 0 there. I was left with 0 up here as well. When I do this, make sure that you are distributing this to both terms. This is negative 10, a minus 8, because I'm distributing the negative to both places. So that means I have negative 18. My answer here is going to be x plus 4 minus 18 over x plus 2. What's that minus 18 over x plus 2? Why is it there? Well, when I get that minus 18 and I ask myself, okay, can I multiply this 18 by anything to make it look like this x? And the answer is no. Yes, theoretically I could multiply this by like 18 over x, but we're not doing that anymore. We're only working with polynomials. Once you have to like multiply by a fraction to make it look like it, or a fraction with your variable in the denominator. You can multiply by a fraction, but not a fraction with your variable in the denominator. Then you're done with your polynomial long division. So once I can no longer just multiply my variable or multiply a coefficient for my variable to make it look like what's ever left, I have a remainder. And then we present the remainder as putting it over the divisor. So here I've got x plus 4, which was what was on top, and that goes down. And then I had my remainder of the minus 18, so I put that over here, and then I have my divisor of x plus 2, so I put it over there. If my remainder was 0, I just wouldn't have to write anything out, and that makes sense. I mean, even if you write out your remainder as 0 over whatever your divisor is, you will quickly realize that you're just left with 0, so you would just have those first couple terms. That's something I don't cover. I want to make sure we're looking at remainders a lot, but we should be able to see if you have a remainder of 0, you're just going to write whatever's on top of the doghouse. All right. Let's look at our second example. Second example here, same idea, pretty straightforward. I've got 2r plus 1 as my divisor. I'm dividing the 8r squared minus 10, or 8r cubed minus 10r squared minus r minus 4. Okay, everything here is pretty straightforward. I'm just going to go through that same process. I ask myself, what do I have to multiply 2r by to make it look like exactly 8r cubed? Well, I have to multiply that by 4r squared. I get 8r cubed plus 4r squared. I'm going to subtract this entire term. Now again, I have to distribute my negatives. So this will become 0. This becomes negative 14r squared minus r minus 4. All right, so now I have to ask myself, I pulled those down, and now I have to ask myself, all right, what do I have to do to make that 2r look like negative 14r squared? Well, I'm going to multiply that by negative 7r. I distribute the negative 7r to both terms. And this should be negative 14r squared, not negative 7r. And now I'm going to subtract this entire thing. I'm distributing this negative to both of these terms, so this actually ends up becoming addition. I've got negative 14r squared plus 14r squared, which is 0. I've got negative r plus 7r, which is going to end up being positive 6r, minus 4. Make sure you pay attention to that. That's one of the biggest issues you're going to run into in your polynomial long division, is you're not distributing your signs correctly. Finally, I ask myself, what do I have to multiply 2r by to make it look like 6r? Well, that's just going to be positive 3. I end up with 6r plus 3. I'm going to subtract everything, and I'm left, as I distribute that negative, with negative 7. And now that I have a remainder of negative 7, I go through the process. I first take what's on top of my doghouse, and that becomes part of my answer. I get 4r squared minus 7r plus 3. I then take my remainder, and I say minus 7, and I put it over what I divided by, 2r plus 1. And that will be my final answer in this polynomial long division. All right, so that's your next example. Again, biggest thing here is making sure you pay attention to your signs. Paying attention to your signs is the most difficult part, especially when you're subtracting everything and you're constantly distributing a negative. So whenever you have that minus sign behind it, if you ever have a negative value and you're distributing, really has an impact on it. All right, finally, I've got this last example, and in this last example, we're going to see, I'm going to set it up. Now, it's going to be really tempting to set it up like this. And don't follow this setup right away. Wait a second. You're going to want to set it up like this. Well, this actually is going to lead your polynomial long division to be wrong. Because even though this is in standard form, and I have this written down exactly, I don't have a u squared term. Now you might be saying, Mr. Yehlen, there is no u squared term. Well, there is. It's 0 u squared. I can write whatever term I want with a 0 in front of it, and it still is there. So I'm just saying that u squared doesn't exist, like in the terms of it has a coefficient of 0. I can totally say anything that's not written in an equation is still there. It just has a coefficient of 0. And it's always being multiplied by 0. I could add that in randomly to any equation I wanted. It's kind of weird, and you might not need to do that, and might not make sense to do it, but in this case, I need to do it. I need a placeholder. It throws off my long division if I don't have that placeholder. So after I write the 6u cubed, I'm going to write plus 0u squared. And I could write minus 0u squared. I can write whatever sign I want, but I need to have that 0u squared in, plus 4u plus 4. If you don't have that in, it's going to throw off all your long division. Now that I'm here, now that I've added in that placeholder, I just keep moving forward. I do exactly what I've always done. I ask myself, what do I have to multiply 3u squared by to make it look like 9u to the 4th? Well, that means I have to multiply it by 3u squared. So I end up with 9u to the 4th plus 6u cubed plus 6u squared. As I go through and subtract this entire thing, I've got 0, that's nice, that works out. Negative 6u squared plus 4u plus 4. So now, I don't have to multiply by any u term, because if I multiply u by 3u, I get 3u cubed. I've already eliminated my cubes, which is nice. So now I have to multiply this entire thing by negative 2. So I've got negative 6u squared minus 4u minus 4. I'm going to go through, I'm going to subtract the whole thing, but again, I'm distributing my negative to all these terms, so this one will become 0, but I'll be left with positive 8u plus 8, because when I have that negative negative, that becomes addition, 4u plus 4u, 4 plus 4. So when I write out my answer here, I'll take what's on top of my doghouse, 3u squared minus 2, and then I will add 8u plus 8 over 3u squared plus 2u plus 2. And that would be my final answer in this polynomial long division. So, pretty straightforward. You just have to constantly ask yourself, what do I have to multiply my divisor by to make it look like whatever term is next under that doghouse? You go through. Biggest things you have to pay attention to, the easiest places to make mistakes, and the mistakes I see most frequently. Number 1, not putting that placeholder 0. If you don't put that placeholder 0, you're going to get a wrong answer. It's going to throw your answer off. And it has to do with like how you line things up. If you see here, when I multiplied this 3u squared by that 2, that's how I got the 6u squared. If I multiplied 3u squared by that 2, and I tried to put, and I'm going to put this in red to show that it's wrong, that 6u squared under here, you're going to probably combine the wrong like terms. I'm not saying you're doing it because you don't know how to do it or anything like that. It's just really tempting to just put them under, not really pay attention to what you're doing. It's a quick, easy, simple mistake to make. I've made it hundreds of times in my life. Everyone's made this mistake. But it's a mistake that we need to do our best to avoid by putting in that placeholder 0. And then the other thing is making sure the distribution of the negative. Now this is a mistake I make frequently as well. It's something to easily get caught up in. It's something that easily you can make mistakes on. I frequently make mistakes on distributing my negatives to negatives. It happens, I understand it, but just because it happens doesn't mean we can't try to eliminate it. Pay extra attention as we subtract everything. You guys have a worksheet on Google Classroom. It's a little bit lengthy, but we really want to practice this skill because it's going to become very important for rational functions in a couple weeks. If you have any questions or concerns, please reach out as soon as possible, and have a great night.